Hello, Chemistry 11. Today's lesson, we're going to be talking about math and the math that we use in chemistry. All right. Now, in science, when dealing with any math calculations or measurements in science, we use the SI units, which you've been exposed to probably back in grade 8 or grade 9 as our unit of choice. So what the SI units are is basically a standardized unit so that if you were to go to any other science community in a different country, let's say Japan or Thailand or Eastern Europe or Western Europe, if you were to use this terminology, they know exactly what you are talking about. So for volume in the scientific community, we either use the units of liters or cubic meters. Okay, for masses in grams. Now, some of you might say, well, wait a minute, Mr. Chan, when we measure each other, why do we use, pounds? Or why do we measure ourselves in foot and inches? And that's because we are so integrated with the United States. They use the imperial system of things like pounds or feet and inches that's why it's come into our vocabulary. It's not that it is wrong, but it's just that if you were to go to a different country, not integrated so much with the United States, let's say Europe or Japan or Thailand, and if you were to go for pounds or what and say pounds, they would ask you, what are you talking about generally in the scientific community? An example is if you were to talk to international students that come to Canada, come to Burnaby South to study, if you were to ask them how much they weigh, they would actually give their weight in kilograms, and their length would be in centimeters or meters. So just something for you to be aware of. Okay, so density in the scientific community is mass over volume or grams per liter, and length is usually in meters. Now, one thing for you to be aware of is that to convert grams and pounds, like what I was talking about, what happens is, 1 kilogram is equal to 2.2 pounds. Okay, so that's something for you to be aware of. All right. Now, for pressure, there are actually three units that can be used to describe pressure. One of them is called kilopascals, or another one, or pascals. That's just a unit to measure pressure. Atmospheres, or millimeters of mercury. Now, the relationship between the units is 1 atmosphere is equal to 760 millimeters of mercury, or it is equal to 101.3 kilopascals. Now, another thing, it could be 101,300 pascals. Pascals is with the PA. Okay. Now, because pressure has 2 or 3 different units, you should know how to convert between the two. All right. So for example, let's say we had, let's say 400 millimeters of mercury. You want to find out how many kilopascals that is. The one thing you should recognize from this conversion is 760 millimeters of mercury is equal to 101.3 kilopascals, APA, sorry. And so what do we do with this relationship is we cross multiply. And how that works is we take 760 millimeters of mercury all over 101.3 kilopascals is equal to 400 millimeters of mercury all over X kilopascals. Oopsie. Kilopascals. And you cross multiply. I think you remember that in grade 8 math or grade 9 math. And then you get an answer of how many kilopascals? KPA. Now, one thing is this, and let me see if I can do this really quickly. So I do 101.3 times 400 divided by 760. So I get an answer of 53.3 kilopascals. Now, one thing you need to be aware of is a lot of the math that we're doing, that we will be doing in Chemistry 11 is a lot of this conversion. So if you were able to pass Math 9, you should have no problems with the math in Chemistry 11. Okay. Now, for temperature, the units of temperature, we actually have 3 different units that we potentially can use. It's either degrees Celsius, Kelvin, or Fahrenheit. Okay. Now, most of you are familiar with degrees Celsius and Fahrenheit, and you may never have been exposed to Kelvin before, but Kelvin is used in chemistry as another way of measuring temperature. And you'll be exposed to that a little bit later on in your first year chemistry courses, or if you plan to take, if you're an AP or Chem 11 honors, we'll be using that a little bit later on. So let's say, for example, here, you wanted to go from, I don't know, let's say 390 Kelvin to, let's say, degrees Fahrenheit. Now, the first thing you will notice is that the common factor between the two is degrees Celsius. So the first step is you take Kelvin is equal to degrees Celsius plus 273. You go 390 Kelvin is equal to degrees Celsius plus 273. And then degrees Celsius would be 117 degrees Celsius. The next step is to plug this answer into this formula. Degrees Celsius is degrees Fahrenheit minus 32 times 5/9. So if we plug it in, we have 117 times 9/5 is equal to degrees Fahrenheit minus 32. The degrees Fahrenheit would be, let me see, 117 times 9 divided by 5 and 32. So that would be 242.6 degrees Fahrenheit. Okay. Now, again, the reason why we use Fahrenheit is because in the States, again, we're integrated with the United States. And so some of their units and terminology is used up here in Canada. You can see that a lot in your cooking books because what happens is if you look at cookbooks, they give you the temperature to preheat an oven is in Fahrenheit. And why they use Fahrenheit and not degrees Celsius is because the publishers and the authors are generally American. Okay. Now, to expand volume, mass, density, length, and so on, we use the SI prefixes. The SI prefixes are used to form decimal multiple and submultiples of SI units. So I've given you 2 examples here, like 1 kilogram. So the K, what happens is the letter K represents times 10 to the 3. Okay, and the C represents times 10 to the negative 2. These are common ones that you'll probably be familiar with in early on in Math 8 or Math 9. Now, here is a general way to read SI prefixes as a review. So let's say we had 45, let's say milligrams. The first letter generally is the SI prefix. And the G that we have here, this would be the unit of measurement. Okay. Now that is general. So usually the first letter is the SI prefix and the second letter is the unit of measurement. It doesn't always work that way, but 95% of the times it does. Okay. Now you might say, well, what SI prefixes do I need to know? So if you take a look, I think on the back of your notes, what you have is you have a list of SI prefixes. Okay. So some of you are familiar with some of this already from your everyday life. For example, giga. Oops. So let's say you have giga, or you have tera, or you have mega. You use that in your computer systems. You talk about 5G or 3G or the amount of memory. So you're familiar with that. So what I'm going to ask you to be aware of is everything from 10 to the 12 all the way to about, I believe, let's do nano. You should be aware of. Okay, so if I said something was micrograms, you should know that that means it's 10 to the negative 6 grams. If I said nanograms, that would be 10 to the 9 grams. Okay. Now, again, remember I said that there are exceptions to this little rule that I gave you about the first letter being the SI prefix and the second letter is the unit of measurement. If you take a look, deca is DA. So there are actually 2 letters, okay, to represent the prefix. Okay, now, when we do the SI prefixes, we need to do a unit conversion to find our answer. Okay, before we used to call it the factor label method, but all I'm going to do is just do cross multiplication. Now, let me give you 2 examples. So let's say example number 1 is something very straightforward. Let's say 45 millimeters is equal to how many meters? Now, the one thing you first need to recognize is what is this prefix? Okay, so what is this particular prefix? Okay, so in this case, what you want to do is you look at the relationship. So the relationship is 1 millimeter is equal to 1 times 10 to the negative 3 meters. So the milli represents times 10 to the negative 3. Now, how did I know that? Is if you go down here, you have milli is times 10 to the negative 3. Now, so going back up here, what we do, that's the first step. The second step would be cross multiply. How do we cross multiply? So then what you do is you take your relationship. So you go 1 millimeter all over 1 times 10 to the negative 3 meters is equal to 45 millimeters all over x meters. Then you cross multiply in math, like in math. And what you get is 45 times 1. So I get an answer of 0.045 meters. Okay. Now, when you take a look at this, you might say, hey, Mr. Chan, this looks familiar to what you did up here, where I found the relationship between millimeters of mercury and kilopascals, and then I cross multiply. Yes, you can do that. It's exactly the same. So basically, for this particular math that you need for chemistry is, can you recognize the relationship? And then can you cross multiply? Now, let's give you something a little bit more challenging. So let's say, for example, here, I'm going to use the same numbers, but in this case, I'll say 45 millimeters squared is equal to how many meters squared? Again, you might say, oh my gosh, what do you do here? You basically do the exact same thing. So first of all, you find the relationship. Is 1 millimeter is equal to 1 times 10 to the negative 3 meters. But now what you do is you square, because you square it. And then you cross multiply. So you now have 1 millimeter all squared all over 1 times 10 to the negative 3 meters all squared is equal to 45 millimeters all squared all over x meters squared. You have 1. So I get an answer of 0.123445 meters squared, or it's 4.5 times 10 to the negative 5 meters squared. Okay. Now, so the reason why I chose the same questions, the same numbers, I just added the square, is just to show you that you're still doing the exact same steps. It's the relationship. And then you cross multiply because you are converting the units. So at this point in time, all I want you to be aware of is the fact that you are working on the process. Now, if you take here and you have a complex conversion example, it says a student went down to the United States and bought $60 Canadian of gas. How much does the gas weigh? Use the following conversions to help you. Now, you might say, well, Mr. Chan, this is pretty tough. Where did you get this question from? This was actually a first year chemistry class. The first day, day and a half, is they use that as a review of things that you should know from high school. So in this case, this was a question that a former student came in and asked me to help them answer. Okay, now, so how do you start it? You basically do a series of conversions. Now, what I'm going to ask you to do is I'm going to ask you to try it out. So I want you to try it. And your answer should come out to about 57,900 grams-ish. Okay, it's around that. I can't remember exactly. So what I would like you to do is try it using a series of conversions. Okay, so you might want to find the relationship and cross multiply at every single step for you to try out. All right, thank you very much. Again, do come to class and see what is the homework assigned on the homework board for this particular lesson. Thank you very much. Have a good day. Bye-bye.